Intro into GitOps. GitOps is continuous delivery for your infrastructure and your applications. In the end, your user doesn't directly interact with your Kubernetes platform, but with Git and the CD tool, in this case ArgoCD, is notified or checks Git on a regular basis to then reconcile your infrastructure and keep it in the state of your desire that's kept in Git. Why would you want to use it? First of all, for repeatability and consistency. So you always can go back in the Git history because your different versions are tracked. And you always have the same configuration. If you have a single source of truth, you can deploy to different stages, different clusters, and always have the same configuration. As already said, single source of truth. It's only one place where all your configuration is for your cluster, so you can't have diverting configurations. You also have the possibility to audit changes and see who changed what, when, and why in the Git history. You can easily collaborate with your teammates and colleagues because you can use the Git workflow and have branches and merge requests, so you don't interfere with your colleagues' work. Yeah, the deployments are faster and safer because you don't have to deploy manually. You only have to change your configuration in the Git. Yeah, and for the rollbacks, as I said, you can always have your history in Git and use an older version to roll back. Maybe for databases there is a problem. If data inconsistency occurs, that's something where you still need a backup, but for most of the stateless applications you want to run in Kubernetes, this is very easy. Also, to a different cluster at a time to have a disaster recovery strategy. That's the special thing for cluster management with GitOps using the cluster API. It has some key benefits. You have an easy version management for upgrading your clusters and also for having different kinds of clusters. You have automatic rollout capabilities for some baselining stuff like monitoring, logging, and similar tools for all your clusters. And you can have multiple people in your change pipeline to have to approve your updates, so not somebody doesn't accidentally upgrade the cluster and cause a downtime. This is just done with normal Git tools like pull requests and merge requests. There are some requirements to do this. As I said, we are today talking about ArgoCD in combination with the supervisor cluster. For that, we need a cluster admin privilege on the supervisor to create service accounts, which we then can use with ArgoCD to automatically create resources and automatically change and delete resources. We need a network connection from our ArgoCD to the supervisor API, so we can then let ArgoCD interact with it. We need to alter the default ArgoCD configuration for some resources because we want to have least privilege on the supervisor. So we would instruct ArgoCD to have only the bare minimum permissions on the supervisor. And we have an automatic onboarding of workloads. That's the secret thing I was talking in the agenda before, which will come later. So how does this look? You would have your normal supervisor cluster with your workload clusters, and in some workload cluster or also in the cloud or at some other cluster you have some ArgoCD instance, and this ArgoCD instance is connected to a Git repository where your cluster definitions are, or Helm charts, or whatever you like to create your clusters, which deploy the cluster to your supervisor cluster. That's just an example picture for how it looks in ArgoCD. As I was only asked to do this presentation 2 days ago, I had no time to prepare it in my lab, sadly, so I don't have any more screenshots than that. but it's just your ordinary ArgoCD application, but instead of being a deployment, it's a cluster. Yeah. So the biggest challenge is what we're talking about next, which is the secrets challenge, because you need to authenticate in the workload cluster, and you don't want to have secrets in Git repositories. That's where something comes in really handy with the newest vSphere Supervisor version. You can also run pods on the supervisor cluster, so vSphere pods, without the need for NSXT. And we use this with cron jobs that create pods on the supervisor to then run a script that fetches the secret that's already on the supervisor, containing the credentials for the workload cluster, to create us a new service account on each workload cluster when he's created, that we then sync to ArgoCD, which we then can automatically use to deploy stuff to that cluster. To be more precise, in the setups I use with my customers, we have some Helm chart which creates our definitions that will be deployed into the supervisor. So we don't have some tons of Kubernetes cluster manifest in here or some cluster manifest in here, but a Helm chart which then creates the cluster manifest and also the cron job. The cron job gets some configuration from our Helm chart with some labels that the cron job then adds to this secret, which is just the configuration for ArgoCD to know about the workload cluster. So if you're familiar with ArgoCD, you already know that each cluster you attach to ArgoCD is in the end just the secret in ArgoCD's cluster, with some special put in some extra labels here that the user can configure in the values file in the Git. For example, monitoring enabled yes, no, or ingress controller kind, if you want an ingress nginx, contour, whatever. We put it in the labels, and after that we put the labels onto the secret, so ArgoCD knows what baseline it needs to deploy on this cluster. So here's written down the steps. As I said, the user creates a simple YAML, which is the values file for our custom Helm chart, where they just need to specify things like I need 5 worker nodes of size L, XL, whatever, and I want monitoring, and maybe I also want an ingress nginx. This YAML file has a custom syntax as it's the values file for our Helm chart. ArgoCD then picks up the values file via an app set and creates the cluster and the cron job. The cron job then creates our secret, which contains all the labels that are configured up here in the YAML file. And after that, our app sets that are already in the ArgoCD setup pick up the labels with cluster generators and then deploy the baseline to the different clusters with the different settings. Yeah, that's fast forward the whole process of doing so. The interesting thing that we don't need to do anything manually in here with the secrets or the authentication for the workload cluster, as we do it via the supervisor cluster's secret in the corresponding namespace of the cluster. Here. That's more or less the basic steps. We can also go deeper into each of these steps. As I said, I didn't have a lot of time for preparing the presentation, so my slides are ending here. But I would be really glad if you have any questions or could say me which topic you want to hear more about, because I can tell you, I guess, 1 hour about each of these topics, but I don't want to bore you guys. Would there be any questions? You get the microphone for the stream.
Can you tell more about secrets? So how ArgoCD connects to the vSphere, for example, and where it stores the credentials?
Okay, so if you create a Tanzu cluster, a workload cluster, the supervisor always creates the cluster itself with its machines and so on. But there are also some secrets that are called like the cluster with some appendix behind it, where there is the kube config for the cluster admin for this workload cluster. And with this script, we pick up this secret because we can mount it into this pod as we are running in the same namespace. So we have cluster admin for this workload cluster inside this cron job. And with that, we create a service account on this cluster with only the necessary privileges for ArgoCD, and this service account we use to create that secret. So I'm working currently on a kind of tutorial blog post on how to do this with the code samples, but it would be overwhelming if I just put 100 lines of code on the presentation. That's why I didn't do it. But there's a QR code to my blog in the last page where you can follow me. And in the next few weeks, I will publish a post with detailed instructions on how to do it.
And where are you deploying the ArgoCD?
The ArgoCD, so for my preferred strategy is to have the supervisor cluster and create the first cluster more or less manually, which is a kind of shared service cluster, because as you may know, first vSphere namespace you create with the supervisor cluster nodes are double homed in that. So that's kind of a management network, and I don't suggest my customers to use it for their workload. So we put our service cluster in there, in the first vSphere namespace, and that's where I run the ArgoCD. In the end, I just deploy the ArgoCD via Helm install, where there is already some secrets and the Git repo in it for ArgoCD itself. So that's just the basic ArgoCD install with Helm. And after that, ArgoCD starts to control itself and update it with all the configuration you need. So theoretically, with this setup, you could tear down everything, create a new supervisor, create one cluster and deploy ArgoCD, and everything will come back. For sure, if you have persistent data, you need to recover backups, but for stateless services, that's 100% doing it on its own. Just need one Helm install and all the rest comes back from the Git.
Thank you.
Did I answer your question?
Yes, yes.
Perfect. Anybody else? Well, I think then we are finished a bit early. As I said, here is some QR codes where you could check out my blog or company website. There's also my LinkedIn and socials on my blog if you want to connect. Yeah, and I would be happy if you reach out and give me some feedback also about the blog posts and the upcoming tutorial. Yeah. And the last but not least, these are my best supporters, my cats, and I hope I see somebody of you maybe at KubeCon 2025 in London. Thank you.